All right, so this is a droplet of water falling into water. So the blue here is air, the red is water. This droplet is 2.5 centimeters in diameter, so about an inch in diameter. And it's really cool. So as we play the video, it drops down and you can see that it's now changed shape. It's more like an upside down kind of bell. And it enters the water and it makes a big splash. You can see those two ridges forming here. But one thing to note is how high up the wall the water goes. So this red region, how high up this water goes on this first drop here. This is an interesting thing to note. Now in the middle, you can see that the water is coming back up. So there's this rebounding effect kind of thing. And it gets quite high. But just now we're seeing this first wave hitting the walls and see how far up it goes. Not very. That's it. So that's not much. Now there's the rest of this flow that got rebounded up and is coming back down. That's going to send another wave on each side to the wall. And the flow goes really high now. So it seems like when that drop was falling, there was so much kinetic energy in it, but it was a small package, so it didn't really send all this water up the walls. Then in the second point where the flow then went back up and then came back down, the kinetic energy had dispersed a little bit, and then there was a lot more water being sent towards the walls. And with this video, this shows the U magnitude, but it doesn't show you really where the water and the air are different. So sort of that line there, that light blue line, is where the water is different to the air. This upper region is the air. And the interesting thing about this video is that it shows you not only the velocity in the water, but the velocity in the air as well, as this drop here is going to be falling down. So you can see as we press play, it comes down, and that bit of water, that droplet, is traveling very fast, 1.6 meters per second. It's pretty cool. And then as it hits the water, obviously the water splashes up and you get that increase in velocity, but the air around it is also accelerating in some direction. So it's really the highest velocity is really on the water surface and the air just above the water surface. So you see here, this region here, these two regions, the blue and that yellow, actually the air, and there's some sort of roll up happening with this rest of the water going up the walls. And now this is the same sort of picture, but this is the vorticity magnitude. So again, you can't really see where the water and the air meet at the moment. You will in a second. You have that water droplet falling, and this just shows you the vorticity in the air and the water as the droplet goes down. So now you can see that already this droplet has pushed a little bit of air down and trained a little bit of air as well. And it's also made the water surface visible with that air. And as the droplet enters the water, you not only have vorticity in the water, you also have vorticity on the air, in the air. And you can see this vorticity that's been left behind by this droplet falling down in the air. And as the water goes up the walls, these vortices sort of form, or at least vorticity forms. You can see all this vorticity forming around this droplet and that water rebounding up and down. And you can see that those vortices are going up the wall, as we were looking before. So it's pretty cool how the water, as we don't usually often think, the movement of the water creates vorticity and moves the air as well. So that's pretty cool to just think about again. So that's it. Make sure to check out the Atmosphere Hawk. It's an instrument that we make here at Aerodynamics. It makes all of your experiments better.